In this example, I'll tell you how can we use the Bayes rule or the possibility a maximum possibility hypothesis in the real world. For example, if we have ATK result, the ATK, the antigen test kit in the COVID-19 for the COVID-19, I'll talk about this. For example, if we have the confusion matrix like this, I'll talk about the false positive rate and the false negative rate, and we'll try to understand what they are talking about this and how can we use in the real world. So if we have the confusion matrix like this, if this is the predicted, I will use the predict values here, and this is the actual values here. This is the positive, negative, and the positive and negative. The positive means that it is the disease, okay, for positive COVID-19. So in this column, it is the correct one, right? This is a true positive and true negative. The result is positive and it's correct, and the result is negative and it's correct. Okay, so we have talked about many people talk about the word false, positive, and false negative. So this is the part that is, oh sorry, this is the part that is correct here. Oh, I would like to use this color. This is the part that is correct, and this is the portion that is not, that is incorrect. Okay, this part, it is this one. It predict as the here, this part. It predict as negative, but the actual values is positive. So this one is false negative rate. False negative, and this is the false positive, right? Because it's predict as the positive one, but it's incorrect. So this one is false positive, and this one is false negative. So we have a lot of things to think about this, and when you talk about some numbers, you have to know in exactly what are they. For example, if someone talk about the false positive rate, in machine learning, the false positive rate is the false positive divided by all negative, or the false positive divided by here the false positive plus the true negative. Okay, so it's divided by all negative, because the false positive is the negative that predict as the positive, right? Because it's false positive, right? Actually it is negative, but the predicted values is positive, so this one is actual negative plus true negative. This one is false positive rate. For all negative one, for the one who doesn't catch the COVID-19, how many of them that the ATK test and report that they are positive? This is a false positive one. And the false negative rate, is false negative divided by the positive. Okay, so in all cases that they are positive, and how many of them that reported as the negative one? So for all positive, it is the true positive plus false negative. And here, this is a false negative. Okay, so once we know the meanings of this, when someone talk about the false 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 positive and false negative. You may think that for the false negative, for example, we have to check that, for example, if the false positive rate is just 3% or it is 0.03, or in false negative rate maybe 20%, for example. This is 0.2 for an ATK test kit. Maybe it should be maybe. So what is the meaning of this? It is that for all positive, for the one who actually be the COVID-19, 20% of them will be tested as the negative one. Okay, and for the false positive rate, for the one who is not COVID-19 cases, the result will return to be true, 3% of them. So the problem is, in the case that the ATK give the result, the positive result, you have to think about that. Oh, okay, what is the probability that I catch the COVID-19? So if it is positive, so the one that you have to think about this is you have to compare between the probability of the one that you already know that is the positive one, and COVID-19 and positive, and compare this with not COVID-19 given positive result. Okay, and in the case that the ATK give the result to be the negative, you have to think about this is are you COVID-19 given negative or not COVID-19 given negative. Okay, so now you know that, or how can we get these two results. So I would like to move this one down. Okay, and then we have to compare between these two. So given positive, the probability to be COVID-19 is probability of plus COVID-19 times probability of COVID-19 divided by probability of positive. And for this part, it is the probability of positive given not COVID-19 times probability of not COVID-19 divided by positive. So the result from your the manufacturer of the ATK over the lab say that the result of the ATK is like this. So we have to fill in first. For the false positive rate to be like this is the values of probability of not COVID-19, right? This is probability of not COVID-19, and the result is positive, right? So in the case that it is not COVID-19, it will give the result to be negative. So this one, this is 0.03, this one is 0.97, or 85%, 97% correct. in the case that it is not COVID-19, right? And the positive result returned is 3%. And how about the false negative one? For the false negative one, in the case that you already know that this is COVID-19, this is the COVID-19, and it returned positive. And the case that it is COVID-19 and it returned negative one, so this one is 0.2, so this one must be 0.8. Okay, so now we have these values already, right? So in the case that COVID-19, I will label it using this color. Okay, so this part is here. Okay, and this part is here. So we don't need to calculate probability of positive because they are same, right? So we can remove it. And the probability of COVID-19 and not COVID-19 for today, maybe it's like the number of current cases, maybe for each day is like 10,000 something. Or if you specific in some area, like in Bangkok, it is like 1,000 or 2,000 by 5 millions, for example. So the probability of COVID-19 is, I would like to make it like 5,000 by 5 million, for example, for some current cases. Okay, so it is 1 by 1,000, that is 0.001. And for the case that is not COVID-19, it is 0.999, right? It is 1 minus this one. So I would like to move it down a little bit. Okay, so this one, for the positive, given COVID-19, it is 0.8 times probability of COVID-19, that is 0.001, and this one, not COVID-19, and given the positive result, it is the 0.03, and the probability of not COVID-19 is 0.999. So it is, this one is 0.0008, right? And this one is 0.297. Oh, sorry, 97. Okay, so you can see that if the ATK in this case, if the ATK return positive, with the result from the lab like this, so the probability of not COVID-19 is much higher. Or maybe you can think that because the values of this number, the actual not COVID-19 is very, very high. So it calls that if the result return positive, you can think that, okay, it is you still not COVID-19, not actual COVID-19. Okay, so this one is like an example. This is an example of uh, when the ATK return positive. Okay. So if you want to check that if the ATK return negative, how can you believe it? So it's like you have to think about the case that negative give sorry um, this one is the probability of negative COVID-19 times probability of COVID-19 and probability of negative given not COVID-19 and times probability of not COVID-19. So we have to find that in the case of COVID-19, that is this part, right? This part in this case, COVID-19, and which this is the lab, the ATK return negative. So this is false negative. This is false negative divided by true positive and false negative, right? So this one negative, this part I've used different color. This one. So we have this color negative given COVID-19 and negative given not COVID-19. So the values will be here divide by pop of positive and divide by pop of negative. That is, they are equal, so we can remove it. For this one, so these values will be 0.2 times probability of COVID-19, that is 0.001, and this one negative given not COVID-19 is 0.97. So it will be 0.97 times 0.999. So, this one is very, very high, right? This one is very, very low, 0.002. And it's too much, almost 1. Okay, around 0.969 something. So it's very high. So if you apply the COVID-19 ATK in current situation in Bangkok, for example, if the antigen test kit return positive, you can still think that the probability of negative is of not actual COVID-19 is much higher. And if the result return negative, so you can be sure that this one is negative. Okay, so it depends on these values. This is very high, right? This one is very high. So in some cases, you may think that I need some ATK that give these values much better than this. For example, 0.002, and this one is 0.98. So this one will be 0.98, right? And this is still stem. So it will be 0.00098. Sorry. Okay. Yes. So it's still less than this one, right? So because this value is very high, so you have the prior knowledge that okay, the probability of catching COVID-19 is just only 0.001. There's 1 in 1,000. So the ATK result, if it's returned positive, you can still thinking that okay, it's not actual COVID-19. Okay, so I hope that you get the idea of how can we use the Bayes theorem. Okay, I hope that you enjoy this example.